All right, 10.2. And with what we did in 10.1, it actually makes 10.2 really easy, because they're going to ask you to convert between radical and exponential. Okay, so we'll do a few different examples, because once we see a couple of them, it should be pretty straightforward. So here's what we're going to do exactly like we did on the last problem. That we're going to take this x that we have here, you're going to take 17 and divide it by 5. And that's it. That's where you're going from radical form to exponential. Now, they're going to mix it up where sometimes you've got some numbers, sometimes you've got variables, sometimes you've got all kinds of different things. So just give you a few examples, because once you've seen a few of them, it's pretty straightforward. It could be, let's do the second root of 17, let's not use 17, about 19, to the 6th power. So you've got 19 to the 6 divided by 2 power. And in that case, 6 divided by 2 is 3, right? So if you get it to simplify, now I don't think they want you to actually go back and multiply this thing out. So they would probably just tell you to leave it in exponential form. So in that case, you could just leave it as 19 to the 3rd. If they tell you they want you to actually multiply it out, they would tell you, but just leave it in exponent form. Just leave it, yeah. Because they say just to rewrite it. They don't actually want you to simplify it. So just leave it just like that. Because on these, it doesn't say to solve it. It just says you're just going to convert it. So you're just changing it from one form to the other and not really actually telling me an answer if there's an answer to it. So let's do this one. Here's one where we're going to do the 8th root of 13. Okay, in this case, there's no power on the 13, right? But how many 13s are there? There's an understood 1, right? So if they don't give you a power on the inside number, just got to realize that 13 is there, so it is 13 to the 1st power. So this one would be 13 to the 1 over 8 power. Let's do the 5th root of 7 to the 2nd power. So you've got 7 to the 2/5. And that would be as far as you go. So the biggest thing on this section, in the very first few problems that you get, they're not asking you to do anything to it, just simply rewrite it. And on the flip side of it, they're going to make you go the other direction. They're going to give you a number that's in exponential form. And then ask you to rewrite it in radical form. So you got 10 to the 1/2. So what you've got to realize is your bottom number that's here, that's the number that's inside your square root right here, or your radical. The power would go here. So this is your power, and then this is your root. And the root always goes here, and the power should go on the inside. And again, if it's 10 to the 1st power, in that case, you really wouldn't have to write the 1 because it's already there. And same thing with the square root. If it's square root, you don't have to put the 2. So for that one, you just put square root of 10. Mm-hmm. Go y to the 4/5. Okay, biggest thing is your bottom number is your root, that has to go on the outside. Top number is your power, that goes with that number on the inside. And that's it. That's all you have to do. And again, there's no working these out. It's basically just, they just want you to realize that when you change one form to the other form, this is where everything goes, and you're not having to simplify any parts of it. Okay, and then the only other thing they give to you in section 2 is this is rational exponents. And this is non-unit fraction exponent with a whole number base. That's a lot. That's a mouthful. Non-unit fraction exponent with a whole number base. Okay, that's a mouthful of a problem. Which basically means this. Simplify. So they tell you all this stuff that now that you've got, basically they're saying on this one, all right, now we're going to give you a number that's got this. We want you to rewrite it, and then after you rewrite it, you have to simplify and break it down. So for this one, first thing is you'd rewrite it. It would be the 4th root of 16 to the 5th power. Okay, now here's what they want you to do. Before you do this one, here's kind of what they want you to do. Do the root first. And then do the power second. So for this one, they want you to do the 4th root of 16 and then come back and do the 5th power. Now, you'll get the same answer either way, but they're kind of looking at this one as, let's just pretend for a moment that we didn't have calculators at all that would do a lot of this work for us. That if you did the 4th root of 16, well, if you think about 16, that's, you can do 4 times 4 or 8 times 2. But if you do 4 times 4, 16 would be 2 times 2 times 2 times 2, which would be 2 to the 4th power. So if you think about 16 as 2 to the 4th power, this 4th power and this 4th root would cancel each other out. And that would just leave you with 2. And now you can just do 2 to the 5th power, so then you can do 2 times 2 times 2 times 2 times 2. Use your calculators. Find out that number is going to be 32. So all those first problems where they just tell you just to convert it from one form to the other, you just convert it, you don't do any simplifying. And then the second problem where it gets this long definition of you're going to use non-unit fraction exponents with a whole number base, that one they're saying, all right, now you're going to rewrite it, and once you rewrite it, you're going to have to simplify and break it down. All right, let's give you a couple more of those. At least one more. Well, that one uses the same thing. Let's pick a different number. A non-unit fraction exponent with a whole number base. Which basically means on that one, You're going to simplify, and you got to tell me just a regular answer when you get finished with it. Mm-hmm. So that's your exponent expression. And now you're going to... Okay. This one, I was looking at what I had on here. It just says non-unit fraction. So, okay, so for this one, you're going to change it over to radical form. So that's the fifth root of 32. And again, I know it is fourth power, but go ahead and put the fourth power on the outside to kind of... Because we're going to do the exponent part of it second. We're going to do the root part of it first. Okay, if you take 32 and break it down, it's a bunch of 2's. And again, we kind of did that back here. If you notice on the problem before it, we did 2 to the fifth power to get 32. So we know that 32 is the same thing as 2 to the fifth power. So where you've got the fifth root of 32, that 32 is the same thing we had here. That's 2 to the fifth power. And as long as you can make this root and that power the same, they'll cancel each other out. Which means that this whole thing would just be 2, so now it's 2 to the fourth power. If you do 2 to the fourth power, that should be 16. So it's kind of back to that same thing. They're going to give you this number that's this root. You've got to take this number and break it down until you've got something to that power, so this power and that root will match each other and you can cancel it out. All right, let's give you one more here that's a different set of numbers. Let's do 27 to the 2/3 power. Okay, so for this one, we're going to start off the same way. That basically, if you rewrite it first, you're going to have the third root of 27, and we're going to square that. If you take the 27 and break it down, that's 9 times 3, which is 3 times 3. So 27 will be the same thing as 3 to the third power. Okay, and if you can get that power to match that root, they'll cancel each other out. So that third power and that third root knock each other out, leaves you with just a 3. Then you're going to do 3 squared, and 3 times 3 is 9. So for all those problems where they start having you break it down and simplify it, you should have just a number answer when you get to the end of it.